What is up, you mathaholics? This is section 4.3, day 1 of polynomial division. And division is actually super important. And factoring things is incredibly important. Factoring like this, you start with something complicated like 140 and simplifying it down, or factoring it down to 2 times 2 times 5 times 7. If you could do that with any number you ever wanted, then you could pretty much hack into any kind of internet security system. They're all based on the fact that this is difficult. Putting numbers in their factored form to find primes, least common multiple, greatest common factor. These factored form, the ability to factor is incredibly important. And so in order to factor, we use division. Here, 140 divided by 5. If you wanted to actually do this example, 140, you could divide it by 5. You can see 140 and then divide it by 5 to test to see if it's one of the factors. And so, yeah, 140 divided by 5 is 28. You can see you can do that by 5 goes into 14 twice. 5 times 2 is 10. Subtract, and you get 4. Bring down the 0, you get 40. 5 goes into 48 times. Let me do that a bit more clearly the next time. So 5 is not a factor of 142 because you can see there's a remainder. 5 goes into 14 2 times. 2 times 5 is 10. Subtract, you get 4. Bring down the 2, you get 42. 5 goes into 42 8 times. 8 times 5 is 40. With 2, that's a remainder of 2. We're going to do the same exact thing with polynomials. And sometimes there's going to be a remainder, and sometimes there isn't. But the whole point is to be able to put polynomials into factored form. This is factored form with just numbers. Factored form with polynomial functions would look like this. This h of x would eventually factor into this. Why is this so important? Because the factors and zeros and intercepts are all related and they're all desirable. We want to know what they are. So here's the finished product of what it would look like. Let me walk you through this step by step so you can copy it down. So you look at x plus 1 and you ask yourself, with this leading term and this leading term, how many times does x go into x cubed? Well, it would go in x squared times, because x squared times x is x cubed. Then x squared times 1 is 1x squared. Now, you remember with numbers, you have to subtract at this point. So in order to subtract, you change the signs of both of these terms, and then you add vertically. So after changing, the red is what the new sign. Okay, so x cubed plus negative x cubed is nothing. They cancel. And 1 plus negative 1 is positive 1, x squared. You bring down the minus 5x here, and you have 1x squared minus 5x. So how many times does x plus 1 go into 1x squared minus 5x? We just look at the front term, x and 1x squared. You would need an x times x to get x squared, 1x squared. Moving with the rest of the polynomial, x times 1 would be 1x right here. So you have the 1x squared plus 1x, and then you change the signs in order to subtract. Positive 1 becomes negative 1, positive 1 becomes negative 1, and so then you can see we've got 1x squared plus negative 1x squared equals nothing. Negative 5x plus negative 1x gives you negative 6x. So what would you need to multiply x by to get to negative 6x? You need to multiply it by negative 6. Negative 6 times x is negative 6x. Negative 6 times 1 is negative 6, or minus 6. Change the signs, and when you add these, you get 0. There is no remainder. So x plus 1 times all of this would give you all of this. And that's exactly what we write. That's just one way to get the new factor here. So x plus 1 is down here, and then x squared plus x minus 6 is right here. And if you were to somehow FOIL these or multiply them together, then you would get the original, x cubed plus 2x squared minus 5x minus 6. But that's actually not the direction we're going. We want to keep on factoring. And if you see, you could use a factor x right here to factor this. When you factor these two, you get it in factored form. So we had to kind of guess that one of the terms would be x plus 1, and because we had gotten a remainder, our guess was correct. We were able to factor out x plus 1, and then once we got it down to a quadratic, we know how to factor those. So this is how you split it up into factored form. Now, I mentioned that x plus 1 was a guess. There was nothing that we had no guarantee that x plus 1 was actually going to work out. It did happen to work out because there's no remainder. But let me show you what it looks like when you guess incorrectly. So x minus 3 is not a factor, but we don't necessarily know that at the beginning. X minus 3, when you start, it looks like this. And you've got x squared, because x goes into x cubed, x squared times, or x squared times x is x cubed. And then you multiply. X squared times x is x cubed, x squared times minus 3 squared. Now I'm going to change all the signs, or change both signs. And then we can see that we get, when we add these two together, we get nothing for the first term, for the x cubed term, and then we get 5x squared here. Bring down the minus 5x, and then we get how many times, what times x will give you 5x squared? That would be 5x. 5x times x is 5x squared. Then 5x times minus 3 gives you negative 15x. I'm going to change the signs so you get negative and plus. And then when we add the two together, we get nothing here. The first terms cancel out, and then a negative 5 plus positive 15 is positive 10x. Bringing down the minus 6, we get 10x minus 6. Then you have to ask yourself, what times x gives you 10x? Well, that's going to be 10. And so you can see this should be plus 10. And then 10 times x is 10x. And then 10 times minus 3 is negative 30. We're going to change the signs. We get negative and plus. And then when we add the two signs together, we get 10x plus negative 10x is nothing, 0. And then negative 6 plus positive 30 is 24. So we get x squared plus 5x plus 10 with a remainder of 24. And because there is a remainder, we can say that x minus 3 is not a factor of h of x, of the original. I want you right now to continue what I've started here. I'll get it started and then you finish it. X squared, and remember, x minus 2 is a factor. I mean, we eventually find that out. So you should be able to do this with, you should be able to factor this. You should be able to continue the whole thing, do all the division, and get a remainder of 0. So let's get started. X squared, you're looking at this first term and this x. What times x will give you x cubed? That's x squared. So x squared times x is x cubed. X squared times minus 2 is minus 2x squared. Change the signs, and you get minus x cubed and positive plus 2x squared. When you add these together, you get 4x squared. Bringing down the minus 5x, I want you to continue and ask yourself, what times x will give you 4x squared? One thing I think I wanted to mention earlier is that there's a relationship between factors and zeros. And you can see here, remember, if you know this to be true, then the zeros are going to be a negative 3. And this x plus 3 right here means that you have a 0 of negative 3. So you just need to be careful that the 0 is the opposite of the number that you write for the factor. Here's the factor, and then here's the corresponding 0. Here's the factor, it's x plus 1. The 0 would be negative 1, because when you put negative 1 in here, you get a 0 in the function. 2 would go here, 2 minus 2 would create the 0. So just be careful that 0 is the opposite of the factor. I wanted to take the time right now to talk about one of my favorite places that I've ever been, Belmopan, Belize. It's the capital of Belize. Actually, I was in Key Cocker, which is very close to Belmo Pen, snorkeling, and that was a lot of fun. So let's do this. Let's group these together, and then I can do this. Great. Now, here is something called synthetic division. And synthetic division is basically, it's going to accomplish the same exact thing as polynomial division that you did on the first page. And if you wanted to divide these two, then there's just a short, you have to write x a lot. Then you have to write all of these different things that are eventually going to always cancel out. Synthetic division is a great way to reduce the handwriting, and it makes things a little bit less complicated. So if you wanted to translate this division problem into a synthetic division problem, there's a lot less handwriting. First of all, with synthetic division, you assume that this term is going to be constant, and then this is the x term, the x squared term, the x cubed term. You have to make sure that they're all lined up. And if we assume that, if they're all lined up, then maybe you don't have to write the x's anymore. We just know that they're there. And then on top of that, if we know that we're going to be dealing with zeros, then why don't we, instead of dealing with the factor x minus 2, let's instead deal with the 0, 2. So we put not the factor, the minus 2, we put the 0, positive 2 here. And then, because 2 is the opposite of negative 2, we're no longer dealing with subtraction, we're just dealing with addition. And that makes things a lot easier. So the way this looks, the way these arrows are organized, is that the down arrows are going to be just addition, and the diagonals are going to be the multiplied by the 0. So what we do is we can translate this problem into 4x cubed with a 4, minus 3x squared with a minus 3. There's an invisible 1 right here, 1, and a 7 right here. Then we take the 0, and we put it here, 2. And then, given this, if this is the question, then this down here is going to be the answer, and this will be the remainder. Let me show you. You bring the 4 down first step, and then 4 times 2 is 8. Add here to get 5, and multiply by 2, the 0, to get 10. Add here, and multiply by 2 to get 22. Add here, and that's the remainder. So this answer is going to be 4x squared plus 5x plus 11 with a remainder of 29. It's polynomial division without all the handwriting, which is actually kind of key. So here, let me show you what I've done. We've translated this polynomial division problem into synthetic division. The coefficient is 1, 2, -5, and -6. The 0, not the plus, it's not -1 right here. The 0 is -1, so we put that here. And then we're going to add, multiply by -1, add, multiply by -1, add, multiply by -1, and add. The remainder is 0. So you can actually see that when you divide this big polynomial by x plus 1, you get x squared plus 1x minus 6. I like synthetic division because it shortens the handwriting, and you're dealing with addition instead of subtraction. Here, we've got this polynomial division right here that we're doing. We're going to take this big polynomial and divide it by x minus 3. Well, you can just put the 0, the opposite of what you see here, because 3 minus 3 would equal 0. You put the 0 here and the coefficients of 1, 2, -5, and -6. So we're going to add here 1, multiplying by the 0, 3, add, multiply by 3, add, multiply by 3, add. You get the coefficients for the answer. 1x squared plus 5x plus 10 with a remainder of 24. I'm going to slow things down a little bit, and I'm just going to do this out by hand. So the 0 is 2. The coefficients are 1, 2, -5, -6. We add 1 plus nothing to get 1, multiplying by 2, the 0, we get 2. Add to get 4, multiply by 2 to get 8. Add the column to get 3, multiply by 2 to get 6. Add the column to get a remainder of 0. So therefore, the answer is going to be, when you divide those two polynomials, you get x squared plus 4x plus 3 with no remainder. I'd like you to start 4C1, copy the problem list, and do the first problem. And I'll see you in class.